Alright, hello and welcome back. We're doing problem 6 of an AP Physics C Mechanics multiple choice test today. So I shortened what I wrote on the paper from what the problem is just to have a little bit more space on the paper, but I'll read it here from you straight from the test. A block of mass M1 is connected by a string to a sphere of mass M2. It's hard to see, but that says M2. Let me bring you a little bit closer so you can see that. That's my diagram. The block is on a frictionless plane inclined at an angle of 30 degrees. Here's our 30 degrees, as shown in the figure above. The string passes over a pulley of negligible mass and friction, and the sphere hangs freely. Which of the following is always true if the block is accelerating down the incline? So, let me get the right pen. So, this block is accelerating down the incline. So the first thing we're going to need to do here, we're going to, basically, this is Newton's first law, Newton's second law. So using force equals mass times acceleration, we're going to sum the forces. But first, before we do all of the mass stuff, we have to make a free body diagram. So we're going to do our FBD on mass 1. So let's make it angled if I can. That's terrible. Mass 1. So the force, the tension in this rope, we'll just call it tension. Actually, no, we're not gonna call it tension. We're gonna call it M2G. I'm gonna say, because that is what this force is equal to, pulling down here, pulling this up with the same force as this is being pulled down. That's third law, opposite but equal forces. So M2G. Then we have mass 1 times gravity pointing straight down into this slant here, and then we have the normal force perpendicular to the plane that it's resting on. So here's our normal force. And then since these are on different axes, we're going to have to define what our x and y axis are so that we can properly sum the forces so that we don't have all these different axes going around. We want an x-axis and a y-axis. Keep it simple. So we want to do this in separate steps to keep it simple. So this is also not. I'll do this again. So I'm going to call this our plus y direction, and this our plus x direction. You can see that. And then I'm going to rewrite this using these axes. So again, we have, here's M1. So this force of M2G pulling up, or pulling backwards in the x direction, is going to stay the same. Normal force, still like this. And then our M1G, we're going to have to split into vertical and horizontal components using sine and cosine. So this is going to become our mg sine, M1g sine theta, which is 30. That means that this is going to be M1g cosine 30. So we know this is sine because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, so that matches up with what we've got going on in the diagram. So now we're going to use these to sum the forces. So the direction before we sum the forces, let's check back to the diagram and make sure we're on the right path. So the block is accelerating down the incline. So it's accelerating in the plus x direction. So let's sum the forces in the x direction because that's actually what we're looking at. So let's start with our force pulling it in the positive direction. That's going to be M1g sine theta. M1g sine theta, which is 30 degrees. Subtract the force pulling it in the negative x direction, which we have here, m2g. Alright, and this, of course, force is equal to mass times acceleration. Now that we've done that, we have, let's bring this a little closer so we can all see. Alright, now let's look at the answers to the problem and solve this thing. So, the block is accelerating down the incline. So, does mass 2 always have to be greater than mass 1 for it to accelerate down the incline? No, that doesn't make any sense. If mass 2 is greater than mass 1, it's going to be accelerating this way. It would be accelerating up the incline instead of down the incline. If mass 1 is equal to mass 2, well, look at this. Sine 30 is less than 1. So if we're saying mass 1 is equal to mass 2, then m1g sine 30 is going to be less than m2g, so it's still going to be accelerating up the incline. We can get rid of this too. Alright, m2 sine theta is greater than m1 sine theta. Again, if m2 sine theta is greater, it's going to be going the wrong direction. So, like, what we want to see is for whatever this thing is, for the m1 side of the inequality, it's going to have to be greater than the m2 side because it's going to be accelerating that direction. It's not accelerating here or up, it's accelerating down. So, we want to see m1 greater. So, the only one of these that has that is E. These both are saying m2 is greater, which is never going to be true if it's accelerating down the incline. And this matches perfectly up with our equation. The g's cancel out, of course. Because the g's are the same. It's the force of gravity. So we have m1 sine theta is going to be greater than m2 making this block accelerate down the incline. So, free body diagrams, Newton's second law, summing the forces. Yeah, let me know if you have any questions. Drop some comments below. Yeah, thanks for watching. Check back in for the next video.